Okay. Hello, everyone. This is going to be the presentation for E104 Lab 4. This is going to be the hospital ER differential equations modeling. So over here, we have our first function, which is def ER. This is the function that I'm declaring for the variables and in order to construct the overall output that we desired. So GIRU recovery time, that is the recovery time for GIU. GIU is going to be basically GIU is basically the general intake unit, which is going to be the general intake unit. And then we're going to have the specialized recovery unit. So specialized recovery unit will basically be for cardiology operations. And the general intake unit will basically be your general patient intake. So GIU recovery time. So for this one, we're setting the recovery time as 0.9. The SRU recovery time, which is the specialized recovery unit time, which is going to be 0.7 in this case. And we're declaring our own number of nurses, which is going to be 10, our number of doctors, which is 15, our number of beds, which is 35, and our number of X-ray machines, which is going to be 27. And the number of CT scanners, that's going to be number 34. And the first constant SRU inflow, that's 0.8. That's the SRU inflow constant. The second constant, GIU outflow, which is going to be 0.7 times the GIU recovery time. So the GIU recovery time is going to be 0.9 in this case. Then we have the third constant SRU inflow, which is going to be 0.6 times SRU recovery time. So the 0.6 times the SRU recovery time is basically the recovery time we have up here, 0.7. So we're going to declare our overall capacity as 45 for the GIU. And then for the SRU, we're going to declare our capacity as 40. So the inflow patient SRU, that is going to be 23. And then we're going to have our first declaration inflow 2 is equal to first constant SRU inflow times H0 times 0.8. So this is going to be the exponent of 0.8. So that is the declaring like the inflow patients to the GIU. So basically for the outflow is equal to the second constant GIU outflow times H0, double asterisk 0.8. So that 0.8 is again coming from the outflow from the outflow from the SRU. So the SRU is the specialized recovery unit. So that is the outflow ratio. And then outflow 3 is equal to third constant SRU inflow dot H1 dash dash double asterisk 0.8. That is going to be the outflow from GIU. So that is setting the output equation for the GIU. And then we're going to set up our differential equations. So the first differential equation is going to be inflow dot patients SRU minus inflow 2 minus outflow 2 over the capacity GIU. And our second differential equation is going to be inflow 2 minus outflow 3 over the capacity SRU. So this is just declaring the using the variables that we have set up in this function over here. We're going to declare a new set of differential equations to go in that function, and it's calling those variable values. So these are the overflow conditions. So the overflow conditions are basically if the conditions are exactly met, then we're going to return the dPdt variable, and dPdt is this differential equation right here. It's going to be the first and second differential equation. So if those differential equations are met, then we're going to call this function, call the differential equation functions, and then we're going to return the value to them from them. And then we're going to integrate the equations, which is t is equal to np dot line space 0, comma 10. So that's the number of times to report the solution. So within that range, we're going to be able to report the solution. And then H0 is equal to 0, 0. Those are the initial conditions for the height. So when we when we set the variable, that's the initial conditions. So not for height, but it's going to be rather, it'll be for the SRU or the GRU. That's the general recovery unit. So then y is equal to ODINT, ER, comma, H0, comma, T. That's going to be the integrate. So we're going to ask it to integrate the functions. So integrate ODINT. That's basically setting an integral function from here. So we're importing matlab.pyplot.plt, and we're importing from skippy.integrate import ODINT. So that's a built-in function within Python that triggers the integration. So again, when we come here, so what we have here basically is again the hospital model, because now what we want is four different plots. So one that shows the saturation for the basically is going to show the saturation for the GIU, and then it's going to show the saturation for the SRU, and then one plot is going to show both of them being saturated. So in order to do that, we have to declare that we have to set this equation. We have to set up this entire block, which is right here, because now we want to show different plots. And so that is to set up everything here. The def ER, the capacity GIU, and then the saturation conditions specifically are over here. So if saturation condition is equal to SRU, and then it's going to set H1, and then it's going to set it greater than or equal to capacity SRU, and then it'll saturate SRU because you can't have any more patients coming in, so it's going to saturate it. Or if that doesn't happen, then saturation condition is equal to GIU. And then if HO is greater than or equal to capacity GIU, then diff1 is equal to 0, then we're saturating GIU because no further patients can be admitted into that specific section of the hospital. So if H0 is equal to capacity GIU and H1 is greater than or equal to capacity SRU, then diff1 is equal to 0, diff2 is equal to 0. So this is basically saying, okay, now we want to saturate both. Then no further inflow or outflow patients will be allowed. Else, then we're setting DPD is equal to diff1, diff2, and then we're returning the DPDT value. So we're returning this value, this function value right here, and we're setting it. So this is the declaration, the setting, and then we're returning it. So again, T is equal to NP dot line space 0, 10. So we're setting the line space from 0 to 10, and H0 is 0, 0. And so that is basically saying the time array and those initial conditions. What point do we want to start at? So these are the different saturation conditions. So it's just labeling them. So saturation dash conditions, saturation underscore conditions is basically saying, okay, SRU, GIU, or both. So do we want to saturate one of them, another one, or do we want to saturate both? And then fig axis, PLT subplot 3, 1, fig size 10, 12. That's just setting the axis and what the plot is supposed to look like. Again, for here, we have the same thing. It's just 4i condition and enumerate saturation condition. So these are all the axes declarations, as mentioned in the previous video for this lab 4, that we're basically setting the axes values, and we're setting what line style we want, what the color, and what our labels should be. And the axes are for time hours. The set dash Y label will be patients, comma P, or parentheses P. And then the axes dot set will be NP arrange 0, 10, 1, 0. So those are the arrangement of the axes values. And then this is the axes title. F patient flow with condition saturation. So then now we're going to do PLT dot tight underscore layout. That's basically saying, okay, now we want to lay out the graph and we want to show it. So let me run it. Okay. So here we go. This is when the general intake unit is saturated, and the other one, the specialized response unit for specialty care, that is shown in underscore. That one's not saturated. But for this one, what we have here is, there we go, is basically we're showing the GIU being saturated, which is the SRU saturation. So that's the general, that's not the specialty one. That's the general intake unit. So that's being saturated. And then we have SRU being saturated. So this is all, both of them are being saturated. And in this one, we're just showing that, okay, now we just want the GIU being saturation. And to piggyback here, it's actually just the SRU that's being saturated. That's right. And this one is just the dashed line. So that's showing that, okay, the other one SRU is just being, this is the line, the dashed line over here. So this is with the patient flow with the GIU saturation. So when it gets saturated, it's a linear, as was with this case. In the SRU got saturated, it was like this, the dashed line going a little bit up. It's not exponential exactly, but it is going up. And then when we have patient flow with both saturation, it'll be here. So this is going up, and this is going here. So this is the one where both of them are being saturated. Thank you. That is all.